example 5, we're going to expand out the expression 2x plus 1 all cubed, and then we're going to combine the like terms after this expansion. So the first thing is, when we do a cube, we're going to do the square first. So we're going to do 2x plus 1 times 2x plus 1. And then once we do multiply the first two terms, we can multiply in the third term. So I'm going to do distribution for the first two terms. So we get 4x squared plus 2x plus 2x plus 1. We're going to combine those like terms. And we're going to make sure we don't forget about that extra 2x plus 1. So this works out to be 4x squared plus 4x plus 1. And then we're going to multiply that with the binomial 2x plus 1. Now, in this case, we can distribute three terms into two. We can distribute the three blue terms into the two green terms, or we can distribute two terms into three. Okay, and that's what I'm going to choose to do. So when I do this, I'm going to first start with my 2x. I'm going to distribute into those three terms. And when I do that, I end up with 8x cubed plus 8x squared plus 2x. Okay, that's distributing the 2x, and then we also need to distribute out the other term here. So I'm going to choose a different color. So we're going to distribute plus 1 times all these terms. So we end up with plus 4x squared plus 4x plus 1, and then we're going to combine our like terms. So we have 8x cubed plus 12x squared plus 6x plus 1. Okay, so there's our final answer. And the way we did it was we multiplied out the first two brackets and then multiplied or distributed out the third bracket and combined like terms to end up with this answer. Now, it's really important to recognize that it will not work if I cube these two like this and end up with 8x cubed plus 1 cubed. Okay, this is completely wrong. We cannot use exponents when there's pluses in there, because anytime we do that, it will always work out incorrect. Okay, there's never a chance where this actually works out. So we never apply the exponent when there's pluses in there. For this one here, to do the surface area, we have to account for all 6 surfaces. And so there's 3 different surfaces. I'm just going to shade them. There's one here which I'll do in blue. There's another surface here on the side, and there's another surface on the front. So I'll start with the top surface. It's going to be 2x plus 1 times 2x minus 1. So I get 4x squared becomes plus 2x minus 2x minus 1. I'll multiply out the front side, x plus 2, 2x plus 1. That becomes 2x squared plus x plus 4x, so that's going to be plus 5x plus 2. And then lastly, I'm going to end up with x plus 2 times 2x minus 1. So I get 2x squared minus x plus 4x, so that's plus 3x. And then negative 1 times positive 2 gives me minus 2. So those are the 3 surfaces. So the total surface area is going to be 2 times the blue area plus 2 times the red area plus 2 times the yellow area. It's a little bit hard to see that color, but There it is. I'm going to switch to black here. I'm going to expand out and combine like terms. So 8x squared minus 2 plus 4x squared plus 10x plus 4 plus 4x squared plus 6x minus 4. Combining like terms, I'm just going to get rid of these zero pairs here. Okay, and then add it all up. So I end up with, looks like 8x squared plus 4x squared plus 4x squared gives me 16x squared. The x terms, I get plus 10x and 6x, it gives me 16x. And then there's only the 1 minus 2 ones term left over. So there's my total surface area. And I found that out by finding the 3 different surfaces and then working out the number of sides that those surfaces have, and then expanding out and combining like terms.